Recognized software for building physics and static calculations of glass, windows and facades. Software for your success. sommerinformatik.com.
Good day, I would like to welcome you all to today's webinar. My name is Sebastian Hinmuller, and in the next 30 minutes I will introduce you to our software WINTHS for the determination of the fracture risk for thermal stress. Our webinar today is divided into two parts. First, a short PowerPoint to give you an overview of the software, and in the second part we will go into the software and calculate an example. Then I'll turn off my camera so you can concentrate on the important stuff. We will start with our PowerPoint. First of all, what is this software about? In general, WINTHS is a software to estimate the risk of fracture for glazing that occurs as a result of thermal stress. The calculation in WINTHS is done according to the French norm NFDTU 39P3. How do I start the software? We have a separate button for WINTHS here at Sommer Global. WINTHS is, as I said, a part of our product range that we offer within Sommer Global, next to Glass Statics with Glass Global and next to the calculation of radiation or transmittance, reflectance with WinSLT. One parameter that you define in the software before you enter the construction is the climate and the orientation. This means that you have a mask in which you define the location, where the pane is to be installed, and the orientation of the pane. Likewise, which installation angle should be stored here. With regard to the locations, you can choose from over 3,600 locations in WINTHS, spread over 178 countries. You can search this directory, which is stored, for example by postcode or also by state. What climate sources do we have here? Where does the data come from that is stored in WINTHS? On the one hand, we generally receive the data from the German Weather Service. The exception is the data for Austria, where we use the data from the Central Institute for Meteorology and Geodynamics, and for Denmark we receive the data from the Danish Meteorological Institute. Another parameter for the calculation is, of course, the mounting of the glass pane. How is the pane supported? Is it supported on all sides, free on 3 sides, clamped at the bottom, etc.? What is the condition of the glass edge? How was it processed? Of course, it also increases the risk of fracture if we have poor processing of the edge of the glass. And of course the frame itself. If I have a frame with a low U value, i.e. a low thermal inertia, do I have a medium thermal inertia or a high thermal inertia? Depending on the frame you choose, the U value will change. The standard in this case would be the low thermal inertia, which is also the standard that is currently used in Europe. Now that we have defined the parameters, it's time for the construction. That means we build up the glass pane in individual layers, from basic glass, from composite layers, from interspace. Of course, the coatings, the base glasses and also the surface materials of the individual manufacturers are stored here. Here you can see again in the screenshot which ones we offer for the coatings, for example. We then take a closer look in the software at how to put together such a construction. The result is then a utilization that results from the calculation of the French norm. I.e., a comparison is made, a permissible stress that the glass can withstand depending on the case, is calculated against the thermal stress that results from the data entered into the software. In an evaluation module, you then have the option of displaying the temperature for each orientation and for each point in time separately. I.e., you can choose between the individual orientations, you can set the time. Here we have the 21st of September 2 p.m. for example, and these temperature distributions that result here are then also displayed accordingly in order to go into more detail and to pick out specific installation situations or time-related situations. Another very important point to note are the interfaces. These are possible between the individual modules of Sommer Informatik, i.e. you can, for example, record and calculate a construction in WINTHS. By switching to the other modules such as WinSLT or Glass Global, you can calculate these constructions in WinSLT for radiation, calculate the UG value, transmission levels, and then switch to Glass Global at the same time and have a static verification calculated for the construction you have just made. The whole thing works in all directions, i.e. it is up to you in which program you start with the construction. That was the short introduction, i.e. we will now go into the software and have a look at it. I'll just start WinTHS and log in here. We start here with an empty project, we give it the name Triple Insulating Glass. The task now is to calculate a triple insulating glass pane with a heat protection layer on position 5 and an internal sun protection. We will then also calculate a variant of this with a different glass in the middle pane. Let's start on the left side. I.e. the climate always comes first, we select the climate. What location, what orientation do we have? First of all, I wouldn't take Rosenheim here, but instead we'll select Frankfurt from our climate data. This could just as well be done via the postcode. With a double click we take over the whole thing and in the end we have these 4 standardized days, these representative days for which we calculate. On the one hand the temperature curve and on the other hand the respective radiation intensity, i.e. I also have the possibility here to look at it more closely via this curve. How is my temperature distribution for example for 21.06? And of course also the respective orientation, here I will take southwest as an example. If you look at the whole thing, you will of course get a corresponding distribution of irradiance over the individual hours, i.e. from 1 a.m. to midnight. We now want to calculate a vertical glazing, that's already set here with the angle. And perhaps as a small tip, it would be good not to calculate all orientations at once, instead to take the most important orientations. I'll give you the example of southwest. As a rule, south, southwest or southeast are the critical orientations, especially for vertical glazing. Of course, once you have made the entry, you can always go back and switch all the orientations back on. So next we choose the frames, we double-click on frames. We want to use an all-round support. We also take the glass edge cut here. If you now take other processing or other degrees of processing it will have an effect on the risk of fracture. However, the temperature is not dependent on this, i.e. the temperature distribution itself will remain the same, but the risk of fracture will increase due to factors. For the frame, we will now select the low thermal inertia, which is actually the standard that you should almost always choose. Special cases like the one below here, the two lower categories. Those special cases apply, for example, when something is embedded in concrete, but they are unusual. So use low thermal inertia up here. Now it's time to define the construction. That means we first want a triple insulating glass pane with laminated safety glass on the inside and outside. We'll take a neutral float glass, a neutral glass. I will take the SOMA Informatic standard. Of course, you can also select glass from other manufacturers at any time by double-clicking here. Then the next step would be a composite layer. We will use a PVB film here, and at this point we can change the thickness. We simply change it from 0.38 mm to 0.76 mm. Then comes another glass pane, and the next step would be the argon interspace. We can select this here below. Argon selected with a double click. Here of course also the possibility to change the thickness. We leave the whole thing at 16 mm. As the middle pane, we now take a single pane, again our normal standard float glass pane with 4 mm. Again an argon interspace, then a standard pane, and again a standard pane. What we can also do, we can drag and drop the PVB here. That would be the other possibility. Double-click to change the thickness again and enter 0.76 here accordingly. Now we already have a basic construction, but we still want to enter a coating on the inner pane, at position 5. We will use a coating from AGC Inter pane, a heat protection layer. The I+1.0, that means I can drag and drop this over here again and let it go. Possibly I'll get a combination regulation where I'll get a glass suggested here, but I want to keep my glass and insert the coating at this point. Here we would have already built up the glass, and now we wanted to enter a sun protection as an interior fabric on the inside. I'll take a neutral sun protection with orange color from the SOMA Informatic, which we can take over here with a double click. Then the sun protection is inserted on the inside. Here we also have the option of changing the distance between the sunshade and the inner glazing. Let's just make it 5 centimeters, that is 50 millimeters. Let's confirm the whole thing, and then we're actually done with our input. That means we would now just have a look at the calculation, so I can click on this sum sign up here, go to calculate, and the system will then calculate the whole thing for us. At first sight, the proof would be okay. We have a utilization of 83, almost 84%. Of course, the maximum is on the southwest side, because we have only entered one orientation. Here you can also see the glass pane displayed and the time when the maximum utilization takes place. That would be the 21st of March at 3 p.m. We'll take a look at the proof. We have defined the layered construction here again in overview. You have shown the time on the right side where the maximum temperature or the maximum thermal stress occurs, and you can see that the main problem or the main utilization is in my middle pane, due to the coating on position 5. This gives us a relatively high temperature in our middle pane, but everything is still within the allowed values. We'll take another look at the whole thing together. Here the specifications are defined again. We have also defined the location here and also the indication of where the data come from. And here also summarized again, this stress comparison, which is carried out according to the French standard with all the coefficients, with all the applied coefficients that are used here accordingly. Finally, the overall proof, similar to what you know from Glass Global. Here we also have a summary broken down for all orientations, in this case southwest, which panes get the maximum temperature difference at which point in time. Then you can see that the middle pane has this utilization of 84% at the time on the 21st of March at 3 p.m. There is also the possibility of looking at an evaluation, where we can activate the false colors. We have seen that the main topic was on the 21st of November. Below you will find a bar where you can move the time with the regulator. Here on the upper left side, we would now be at 7 o'clock, let's go to 2 o'clock. You can also let the film run through in order to display this accordingly, so here you can see exactly how the temperatures develop over the course of the day, and we get 55.6 degrees Celsius in the middle pane at 3 p.m., after which the temperatures decrease again. If you had several orientations, you could use this evaluation to select the orientation or the individual days. It is quite interesting that we get a higher temperature in summer, but it's not decisive because of the different temperature differences. This would be the first project calculated. At this point it would be interesting to vary. This is also generally offered by WINTHS SLT or Glass Global. If you have calculated the first project, you can simply save it here and we can now make a second project or a second position relatively easily. So we make a variant of our triple glazing. I click on the whole thing here and we use the function copy current position. This gives us a copy of the position, which we simply adjust again here. I now want to change the middle pane to a different glass. That means we simply use a green glass for the middle pane, where this standard glass is stored. This gives us a higher temperature, because green glass usually has a higher absorption, and therefore we also get a higher absorption in the middle pane, which is why there is also a sharp rise in temperature. So we make it relatively simple here. We just take this glass pane and mark it and simply remove it with the Remove Layer option or the Delete button. Then we take a new base glass. We take a planeable green from the company Interpane. This is simply a glass with a higher absorption. We have 6 mm as standard here, which goes in like this. We want to make the comparison, so we make a 4 mm glass pane out of it again. After that we confirm it. Now we have the whole thing calculated again. After he has done the calculation, you can see right away that if you replace the normal standard pane afloat with green glass, we will now get an excess stress of almost 70%. We can also take another look at how this is represented in terms of temperature. Here we already get significantly higher temperatures of 84 degrees Celsius. If you go further down here, you can also see that the temperature differences, resulting from the 84 degrees Celsius, are clearly visible. We have significantly higher differences here, so the permissible stress of 20 Newton per millimeter squared is clearly exceeded here by the 33.37 Newton which results here. We can also look at this again in the evaluation. If you just go in here, you can leave the film running here. There's the possibility of looking at the whole thing over the course of the day. How are my temperatures developing? A calculation is carried out for every hour, across all orientations. Then you can see quite clearly that we have a clear temperature peak here at 2 p.m. and therefore also a stress peak. What could be done to improve this? One possibility would be not to use green glass, but to use normal standard glass again. Of course, there are other options as well. By default, all glass is deposited as float glass, as you can see here on the right. Of course, we have relatively low permissible stresses for float, these 20 Newton that you can see here. We could simply do the following here. We can also change the glass types again. I'll just do that here. I'll click with the right mouse button on this glass pane. Here I can define a different type of glass. For example, if we select a fully tempered glass float, then you will also see that no calculation is necessary up here. The reason for this is that the temperatures do not change as a result of the change in the type of glass. Only the permissible stresses change. That means if we take a look at the middle pane, we now have a permissible stress of 50 Newton, so I am well below my permissible stresses. We could also try to define another type of glass at this point. For example, heat-strengthened glass, maybe that would be enough. If you select heat-strengthened glass here, we would still be in the permissible stresses. We are already at 95% utilization, but that would be another way of modifying the construction, so that it is okay. Finally, as mentioned earlier, we come to the interfaces. So when we save our project, we simply leave WinThs and assume that I want to calculate the statics for my project that I have just made, then we can switch to Glass Global here. We then also have this construction, which we have just defined, stored accordingly, and we can immediately calculate the statics, assuming we specified certain loads etc. Here we would also have a static utilization of 86% and the whole thing would then also work in the direction of WinSLT. So we simply go into WinSLT, we also look at the construction here again and have the whole thing calculated. Accordingly, we can take out the false colors and look at the temperature distribution with the standard reference conditions, also here the UG value. UG does not work at this point, of course, because we have a sun protection here. Basically, you can also calculate this project one-to-one in WinSLT. That brings me to the end of today's webinar. Thank you for taking part. We would be pleased if you would also participate in our next webinar. Thank you and have a nice weekend.